Hello everyone, welcome back to the channel. Now this is GCSE Physics paper 1 predicted questions for combined science, and this is mainly for the AQA exam board, higher tier. To use this paper correctly, you need to pause the video when you see the question and attempt the question yourself. When you're satisfied that you come up with your answer, play the video and check the answer against yours. You can use different colored pens to do your corrections. And remember, this is just certain possible questions that I think would come up in the exam. So these questions are based on past trends and do not guarantee the coverage of actual exam content. So the exam board can ask anything from the specification. But in these questions, I cover a lot of this content that you can get, especially in the AQA exam board for combined science. So the elements of these things are very likely to be in the exam. Question number 1. Pause the video and try to answer this question. When you're ready for the answer, you can press play. Which type of energy is stored in a wound up spring? Now, whenever a spring is squashed or stretched, it has elastic potential energy. It's not gravitational potential. Elastic potential, yes. Kinetic, that is when an object is in motion. Chemical is the energy in food, fuel, things like that. So the answer is elastic potential energy. Let's go to the second question. Pause the video and give it a try. A student lifts a 3 kilogram weight. Well, it should be really mass here. Okay. The mass is 3 kilograms, m, to a height of 2.5 meters. So this is the height. Calculate the gravitational potential energy. Take G to be 9.8. So the formula for gravitational potential energy is mgh. The mass is 3. G 9.8. Height 2.5. Then you get the answer as 73.5 joules. Capital J is the unit of energy. Question number 3. Pause the video and do this question. State the law of conservation of energy. Now, the law of conservation of energy says that energy cannot be created or destroyed. It can only be converted from one form to another. That would get you 1 mark. Question number 4. Explain why using LED bulbs instead of a filament bulb is more energy efficient. Now, efficiency is useful output divided by the total input. So if you think about it, how can you increase the efficiency? If you have more useful output, that means it becomes more efficient. So when you think about a LED bulb and a filament lamp, the main difference is that LED bulbs waste less energy in the form of heat, whereas filament lamps convert a large amount of energy into heat energy. So if you just draw a simple Sankey diagram, you don't need it here, I'm just explaining it with that. So a filament lamp, maybe this is useful form of energy and the waste is quite big. So this is light and this is heat. But if you think about a LED lamp, the situation is different. You have a large amount of energy converted into light energy and only a small proportion of energy is converted into heat, which is the waste. So this is basically the idea, but you don't really need the diagram like this. I just got it just to explain it. So I'm going to write the answer including these things. So let's see what we need to write to get 2 marks. So we can write LED bulbs convert a larger proportion of input energy into useful light. But filament lamps, on the other hand, waste a large proportion of energy as heat. Therefore, LED lamps are more energy efficient. Next question. A kettle transfers 135,000 joules of energy in 90 seconds and calculate the power. So obviously the formula is power is equal to energy divided by time. So energy is 135,000 joules divided by 90 seconds. And the answer is 1500 watts or joules per second. They are both okay. Draw and label a circuit diagram that includes a cell, switch, resistor, and an ammeter in series. Okay, so here's a cell. Remember, this is a battery. This is a battery of 2 cells. This is a battery of 3 cells. But if the question just says a cell, I'm just going to draw a single unit. Okay, so that's the cell. Switch. Okay, so here's a series circuit and I need a switch. So let's open it like this. Switch. A resistor. Okay, so here's a resistor and an ammeter in series. Okay, an ammeter, and they are all connected in a series circuit. So because it says draw and label, so I'm just going to label it. Here's the cell. State Ohm's law and give its formula. Now Ohm's law says that if you consider a resistor and the current that goes through it is directly proportional to the potential difference across its ends. So V is proportional to I when temperature and other physical quantities remain constant. Now at GCSE level, if you just say temperature remain constant, you're fine. So the formula is V is equal to IR. So here's how you can write it. Current is directly proportional to PD across its ends, across the ends of a component when temperature remains constant or temperature and other physical quantities remain constant. Question number 8. Remember, you need to pause the video and try these questions. Don't just keep on watching it because that's not going to help you that much. You need to try it yourself and then check the answer. A circuit contains a 12-volt battery, that's the EMF, we call it, the voltage, and a 4 ohm resistor, that is the resistance R. Calculate the current. Now, this is a direct application of the formula V is equal to IR. So, 12 is equal to I multiplied by R is 4. So, I would divide both sides by 4, cross these two out, and the current here, I, is 3, and the units are amps. Question number 9. Explain what happens to resistance in a wire as the temperature increases. Now, let me explain this first and I'll write the answer. If you think about a resistor, there are particles like ions, metallic ions, and current is when electrons move through this. So, as the temperature increases, these particles will start to vibrate vigorously. So what happens? The particle vibrations become more vigorous. When the particle vibration becomes more vigorous, the hindrance to the movement of electrons increases. So the electrons find it harder to go through that. So what happens to the resistance? The resistance increases. Let's write this down. So here's what you can write. As the temperature increases, particle vibrations become more vigorous. That's one point. So there will be more collisions with electrons and the hindrance to the flow of electrons increases. So the resistance increases. Question number 10. Describe how electricity is generated using fossil fuels. So fossil fuels are coal, oil, gas, those things. Now it's a 3-mark question, so you're not really expecting a lot of details. So what you need to say is the fossil fuel, coal, oil or gas, is burnt So when it's burnt, it produces energy. Now this energy is used to heat water. Now water is heated and is turned into steam. Now this steam then hits a turbine. So when it hits a turbine, the turbine rotates and the turbine is connected to a generator. Now the generator produces electricity. Now you don't really need a diagram like that. I just did it to explain it. So let's write the answer. So the first point is fossil fuels are burnt to produce heat energy. This heat is used to heat water and make steam. Then kinetic energy of steam is used to rotate a turbine. This spins a generator and electricity is generated by electromagnetic induction. You probably don't need the EM induction bit for pair 1, but that's what really happens. Question number 11. What is meant by the term specific heat capacity? Remember, if you have 1 kilogram of a substance at a certain temperature, let's say 20, the amount of energy needed to increase the temperature of this 1 kilogram of a substance by 1 degree Celsius is defined as specific heat capacity. The amount of energy needed to change the temperature of 1 kilogram of a substance by 1 degree Celsius. Now, the formula for this is E is equal to mc delta theta. In physics, you can make C the subject and define the term, which also counts as a definition. So, I can make C the subject by dividing both this side by m delta theta. So, C is equal to E divided by m times delta theta. So, all I did was just divide both sides by m delta theta, m delta theta. So I get cancel these two. I can cancel these two to make C the subject. Then I can define the term. C is the specific heat capacity. E is the amount of energy in joules, energy. M is the mass in kilograms. And delta theta is the change in temperature. Now, for a question like this, you just need to write this part and you'll get the mark. But I just did this bit as well. Question number 12. Calculate the energy needed to heat 0.5 kilograms of water by 20 degrees Celsius. Specific heat capacity C is given for water. E is equal to mc delta theta. E is equal to m is 0.5, C 4200. Change in temperature is 20. Just put this in the calculator. The answer is 42,000 joules. Question number 13. Explain the difference in particle arrangement between a solid and a gas. In a solid, particles are in fixed positions. They are much close together. They can only vibrate about their fixed positions. They are not free to move. There is less space between particles. In a gas, particles are far apart. There are a lot of spaces and all that. Let's write a good answer to this. There was a 6-mark question asking the same thing some time ago. Again, I think it was 2014, 15, something like that. I don't exactly remember, but there was a 6-mark question to differentiate between the two states of matter, solid and gas. Many students got some marks. I mean, almost everybody got some mark, but not many people got 6 out of 6 for that question because people ran out of points. But this is a 3-marker, so you don't really need that much information. So let's write an answer. In solids, particles are closely packed and they remain at fixed positions. They vibrate about those fixed positions. In gases, particles are far apart and are free to move. Solids have a fixed shape and volume. But gases do not have surfaces. So you can't really talk about this shape of a gas like we talk about the shape of a solid, because gases do not have surfaces and gases can be compressed. I think that's more than enough. You only need 3 points really. This is a little bit too much, but these are some of the things you can write. Question number 14. Describe what happens to the internal energy of a substance when it changes state. Now, this question is a little vague question because they're not exactly saying what change of state taking place. So we have to just think about both ways, but let's just use one of them and answer this question. When a solid changes to liquid, particles gain kinetic energy. So the temperature remains constant and energy is used to break bonds between molecules. So think about ice turning into water at 0 degrees Celsius. So this increases the potential energy of particles. Now remember, internal energy is the sum of kinetic and potential energy of particles. So the internal energy increases. It could be due to increasing kinetic energy. It could be due to increasing potential energy. When it's changing from solid to liquid, the internal energy increases. Now, if it is the opposite, the exact opposite happens. Say, if something is turning from gas to liquid, condensation, or if something is changing from liquid to solid, then the internal energy decreases by the exact opposite process. Question number 15. State two properties of alpha radiation. Now, alpha radiation consists of 2 protons and 2 neutrons, and they are identical to helium nucleus. So let's write some of these properties here. Consists of 2 protons and 2 neutrons. This is identical to a helium nuclei, and the relative charge of an alpha particle is +2, and alpha particles are highly ionizing, and also we can say that they have low range in air. It's about roughly about 5 centimeters, and also you can say they have low penetration power. They can be stopped by a piece of paper. You can write any of these. The question is really asking for 2 properties, so any 2 out of these will get you 2 marks. Question number 16. Why is gamma radiation suitable for sterilizing surgical equipment? Surgical equipment can be, they can put this in plastic wrappers, plastic packets, and then you can irradiate this with gamma radiation. Because gamma has a high penetration power, they can go through this and kill the microorganisms. Gamma radiation is highly penetrative. That's one point. Also, they can kill microorganisms without making items radioactive. So this is a process of irradiation anyway. Irradiation does not make items radioactive. So you can write things like that. Question number 17. Describe the structure of an atom according to the nuclear model. Now, this is Rutherford's model. So, what Rutherford and his students Geiger and Marsden, what they found after using the alpha particle scattering experiment or gold foil experiment was that an atom consists of a tiny positively charged nucleus, and most of the atom's mass is concentrated in that, and then it is extremely small compared to the size of the atom, something to that effect. So let's write this down. An atom is mostly empty space, and most of the mass of an atom is concentrated in a tiny positively charged nucleus. Remember the experiment they did when they sent alpha radiation through a gold foil. Most of the alpha radiation went straight through. Majority of the alpha radiation went straight through. Some few just change the direction by through small angles, and very few alpha particles, when it went straight at a nucleus, bounced back. So Rutherford decided that an atom space is mostly empty, which explains why vast majority of the alpha particles went straight through, and the mass is concentrated in a nucleus. Now that's why it was able to deflect alpha particles, even sometimes very rarely, like completely make them bounce back, and is positively charged because it was able to repel the positively charged alpha particles. Question number 18. A radioactive source has a half-life of 3 days. How much of a 40-gram sample remains after 9 days? Now, one half-life is 3 days. 9 days divided by 3, that's 3 half-lives. Now, each half-life makes the mass half. So, what's the definition of half-life? The average time it takes for the number of nuclei to halve, or activity to halve. Now, we have 40 grams of this radioisotope. In one half-life, this is the symbol for half-life, it becomes 20 grams. Give it another half-life, that's 6 days now, that will be 10 grams. In another half-life, it will be 5 grams. So the remaining mass of that particular radioactive source will be 5 grams. Question number 19. Explain the safety precautions when working with radioactive materials in a lab. So we can use lead shielding to block radiation. Also, you can use tongs to hold radioactive materials away from humans. So there are quite long tongs that you can use. So if here's the person, now rather than holding it in hand, if you use a pair of tongs, so what will happen is now the radioactive isotope is here. So that's far away. Also, using gloves and minimum exposure time is also an important thing, because you don't have radioactive materials lying around, doing experiment and then keep it on the side like that. You use it for the minimum required time. Also, we can monitor exposure. That's another important thing we can do. So 3 marks, a couple of these things we'll get you the 3 marks. So here's the last question. Describe an experiment to measure the specific heat capacity of a metal block. So this is the experiment with the aluminium block. So what we normally do is we take an aluminium block, and then this has a hole drilled into it. Actually, we have 2. And one of them is used to put a thermometer, and to the other one we can use a heater. And then this one is lagged or insulated to minimize the heat loss. And this is connected to a joule meter to measure the amount of energy supplied, or you can connect it to a voltmeter and an ammeter, and you can get the energy like that. And then this is connected to the power supply, and we can measure the initial temperature, say T1, final temperature T2, and the mass of the object can be measured by putting this on a top pan balance. Now, the formula is E is equal to mc delta theta. Now, to measure the specific heat capacity C, you need to find the amount of energy and divide it by m delta theta. So, the reading of the joule meter gives you the value of E. Mass is the mass that you get from weighing it using a top pan balance, and delta theta is the change in temperature T2 minus T1. When you put these values in, you can calculate the specific heat capacity. So I wrote the answer, so you can write something to this effect. Now let's see what we can write. Insert a heater into the hole at the top of the metal block, like this one here. So that will be 1 point. Place the thermometer into the hole and use oil to ensure good thermal contact. Now, if you think about the thermometer, say this is the bulb of the thermometer. Now, this is not exactly in contact with the metal block, and there is air inside. So that might give you a wrong reading. So what we do is we put a couple of drops of oil so that it gives a good thermal contact to the metal. So that could be 1 point. Lag using or insulate using cotton wool to reduce heat loss. Record the initial temperature, we call it T1 earlier. Make sure the joule meter is at 0 because this should start with 0 and then power on. Instead, you can use a voltmeter and an ammeter and you can record the time. And then you can use energy is equal to VIT. That also works, or this one is fine. Then record the highest final temperature. Now that's really important because even sometimes after you turn this off, the temperature might keep on rising. So you need to watch for that and see what's the maximum temperature that it goes to and then record it. So we call it T2. Find the mass using a top pan balance. You can do it. I mean, that kind of, you can even write at the very beginning. You actually do it beginning before you heat this up. So use C is equal to E over M delta theta, which is basically a rearrangement of E equals MC delta theta to calculate the specific heat capacity, because this is the joule meter reading. This is the mass that you measure using the top pan balance, and delta theta is T2 minus T1. That would get you 6 marks.